never feared for anything, never shame but never free. A life that healed the broken heart with all that it could.
Assalamualaikum and hello. Today our group will present about Green's theorem. First of all, I will introduce our group members. My name is Ahmad Izzuddin as the secretary of the group, Ahmad Syairazi as general manager, Zikrie as IT manager, and Abdul Aziz as engineer. First of all, I will explain about definition of Green theorem. In this topic, we are going to investigate the relationship between certain kinds of line integral on closed path and double integral. Let's start with a simple closed curve C and let D be the region enclosed by the curve, as you can see the sketch on the slide. So, based on the sketch, first, you can notice the curve is simple and closed. There are no holes in region D. Also, you can notice that the direction has been put on the curve. We will use the convention here that the curve C has a positive orientation in a counterclockwise direction. Another way to think of a positive orientation that will cover much more general curve as we will see later is that as we traverse the path following the positive orientation, the region D must always be on the left. Given curve or regions such as this, we have Green's theorem. Green's theorem stated that let C be a positively oriented, this-wise, smooth, simple, closed curve, and let D be the region enclosed by the curve. If P and Q have continuous first-order partial derivative, then integral C P dx plus Q dy equal to double integral T in the bracket del Q over del X minus del P over del Y dA. We can also assume that function of P equal to F and Q equal to G. For further explanation, we have chosen three types of question based on Green's theorem and of course related to engineering. So the first example we choose is in electrostatics, the electric field lines cannot form any closed loops. However, the electric field lines in electrodynamics form closed loops, which is entirely based on Green's theorem, such as relation between integral and differential forms of Maxwell equations and the energy of steady currents. Solve the following line integrals using Green's theorem based on the above condition. So, I will let Zikrie to present our first example, followed by Aziz and Razi.
I am Khairul Zikrie. So for the first question is integrate C 1 plus x square dx minus x square y dy, where C consists of the arcs of the parabola y equal to x square from minus 1, negative 1 to 1 and to 1 to 1. So firstly, we sketch the graph, and according to this theorem, 1 plus x square is equal to f, and when we integrate, we get 2 is equal to 2x, and negative x square y is equal to g, and when we integrate, we get negative x square. So we substitute into the theorem equation and substitute from y to x square, and substitute x 1 to negative 1 per negative 2 xy dy and dx. So the final answer for this question is 0 because this is a odd function. So that's all. We continue for the next question.
Okay, Assalamualaikum. My name is Aziz and we will continue to the next question. And this question is integrate C xy dx plus x squared y cube dy where C is the triangle with vertices 0 to 0, 1 to 0 and 1 to 2 with positive orientation. First of all, we need to sketch the graph and we will get the triple line integral for this graph. And then we need to identify the fxy and gxy. For fxy is xy and gxy is x squared y cube. And then we need to differentiate the fxy and gxy. For fxy is df over dy equal to x and dg over dx equal to 2x y cube. And we substitute into the theorem equation, double integral r dou over dou x 2xy cube minus dou over dou y x dA. And dA I will use dy dx. Dy is 0 to 2x and dx is 0 to 1. And we will integrate first dy 0 to 2x and we will get x power of 5 minus 2x squared dx. And last we will integrate the dx and last answer we will get 2 over 3. Okay, next we will move to the next question.
Okay, for the last question is integral dy, where C is the circle, x square plus y square equal to 4. Okay, first we need to sketch the graph for know the limit. Okay, first we need to determine the f and g. So f is x square y and g equal to negative x y square. So we need to differentiate both of function. The f over dy we get x square and dg over dx we get negative y square. Okay, after that we need to substitute into the green theorem formula, which is dg over dx minus df over dy. Okay, so we substitute, then we will get negative y square minus x square dA. Okay, to find the area, we need to substitute dA to r dr dt theta. So for the limit r, we get 0 to 2, and the theta limit we get 0 to 2 pi. So first we need to assume that x equal to r cos theta and y equal to r sin theta. So we substitute into the equation. So we will get negative r cube dr dt theta. First, we need to integrate the r. So we will get negative pi d theta. After that, we need to integrate the theta. Then the final answer, we will get negative 8 pi. Okay, that's all from me. Thank you.
By hearing our guides' explanations, I hope you guys can reach an understanding about Green's theorem. Thank you.
"風に